Hello everyone. So today we will model a 2D truss problem in SAP 2000, and as you can see here we have four different members of the truss structures that are connected together, as you can see at point A, B, C and D, and the cross-sectional area of each member is given. There is 3 square inch per AB, BC, CD and so on. The lengths are also given. And we want to model this problem in SAP 2000, and here you can see here's hinge supported point A and roller supported point B. So let's go to the SAP 2000. As you can see, this is SAP 2000 version 24, and it's a commercial version of the SAP 2000. And what you will do is to go to File and New Model, and then first you have to set the units, and then you can use the grid only in order to model the current problem that we have just shown in here. So you can see we have grid lines both in x direction as well as in z direction. You will take this as z direction. So how many grids do we need in x direction? You can see here is 1, 2 and 3. And what type of unit I should select? So in the beginning you can select any units that is feasible to your problem. For instance, you have here kif, kilofarm, and here is feet, inch. So you can choose either kif, inch, kilo, Newton. You cannot choose kilonewton because here the units are different. So you have to use either kif inch or kif feet. Okay, so I'll choose kif feet. So kif feet, and then the grid only. So in grid only, you have to know how many grids do we need in the x direction. So in x direction we need 3 grids, and y direction we need 1, and z direction we need 2. Why? I'll show you again. So this is the x direction, this is z direction, and the y direction is pointing inside the screen. So you can say like this. This is z and x. So in x direction we need 3, in z direction we need 1 and 2. Now the next thing is, what is the spacing between two grid lines? We can go back to our problem. So the spacing in x direction is 20 feet between point A and D, and 20 feet between point D and C, and for the vertical z it's 10 feet. So going back to SAP 2000, we can see 20 feet. Y direction doesn't matter because it's just one grid, so any value here will not change anything. And for z direction, we need to put 10. You may be thinking, what is the meaning of this one? So this is the first grid line location. We don't want to change that. We're going to keep that by default. And then we can click OK. So now you can see here we have two windows. One is XY plane and the other one is 3D view. But if you remember, we define x in xz plane, therefore we have to change this view, xy view, which is the top view in this case, into xz view. So how would you do that? You just click xz view. If you want to change it to yz, you can click y. If you want to change it to xy or 3D, whatever you like. But we will keep xz view. Now we need to define materials. So in any problem, you will need to define material and section properties whenever you want to model any structure in SAP 2000. So our material properties, we want to see what material properties are given. So for this problem, we can use modulus of elasticity as say 29,000 KSI, and the areas are already given, so based on that we can solve the current problem. So let's do that. So you can add new material, you can add copy of the previous material we have, we can add modify or show material. So let's add copy of the current material we have. First thing you need to change the type name steel, and then we want to see what material, what is the modulus of elasticity. So you can see here we have different units. You can see weight per unit volume, and then we have modulus of elasticity. And kilonewton millimeter usually steel has 200 GPa, so I'll just put that as 200 GPa. If you remember in any other units you can use that as well. Kip inch, it's around 29,000. And then we'll keep Poisson ratio, coefficient of thermal expansion, shear modulus are by default values. We don't have to change Fy, but in real problem if you have any other value, like if Fy is say 52, Fu is 67, or any other value, you can use that. Then okay, so we define the material. The next thing we have to define the section properties. So you can import new properties and you can add new properties. You can see here that we have a different type of steel section, but if you remember in the current example it's not given what type of section is this. The only thing which is given is the cross-sectional area. So therefore the section is not yet defined, and the cross-section is even, so we will go to other and choose general, and with that way we can define a general section. We can give it some name. We can say member 3 square inch. So each member has its own cross-sectional area. Like here we have 3 square inch, we have 2 square, 4, 3, and therefore we have to define each one by one. So 2, 3, and 4, we have 3 different types of section. I'll show you again how I did that. So add new property, other, general, and you have to name it. So member, you can say member 2 square inch. Member 2 square inch. And from here you have to select the right material, which is steel, and then the section property. Here you have cross-sectional area, so you can just put cross-sectional area 2, and the unit here is skip feet, but you want to put it in inches. So to do that, you just click shift and double click, and then you can choose the right unit, and then you can put 2 square inch. That will automatically calculate it in the square feet. You don't need any additional calculator or your mobile in order to convert area, but SAP 2000 can do that job for you. So now we define first material with the 2 square inch area. Now we have to define another material. We have to name that material as member 3 square inch. Okay, and then we can choose the right material that we just defined in the previous step, which is steel, and then section property, and then here 3 square inch. But it's not 3 square, it means 3 square feet. So shift double click and then 3, because it's already kif inch, so okay, it will convert it into that current units, and then okay. Now let's add another material because we have another section too, and that is member 4 square inch. Select materials, steel, section properties, and then here 4. So here you have to put 4 in inches, which I have dismissed. So 4 square inch. Then okay, then okay. So now we define 3 different sections. The next thing we have to define is the load factors. So do you want to include the self-weight multiplier? You want to include the self-weight. If you don't want to include the self-weight, therefore we have to put it 0. If you want, then you will have to put that as 1. So if you don't want, I don't want it, so I will just keep that modifier load factor. And then do you want to consider this load as dead load? What type of load it should be? Is this dead load? Yeah, you can keep it as a dead load because we are not considering the self-weight of the material. Now we are ready to assign those sections according to the given sample. We have A, B, E, C. So the first A, B, and B, C are 3 square inch, and then A, D, and C, D are 2 square inch. Let's go back to SAP 2000. How to assign those member now? So here you can see there is a draw plane or cable. You can just click that and start, and then make sure what kind of section is given. So you have to use the member 3 square inch if you remember. So start from here and end here. SAP 2000 will tell you what is the distance between these points. As you can see here, 22.36. So it's again member 3 square inch. And the next member here is 2 square inch, so we'll go with 2 square inch, and then again it's 2 square inch. And let's check what is the next middle member, cross-sectional area, which is 4 square inch. So let's go back to SAP 2000, and here we will choose 4 square inch. Now then we have to start it again. So 4 square inch. So let's start from here and to the end. Now, if you remember, we have hinge support and roller support. So that's super easy how to assign hinge support and roller support in SAP 2000. Let's go to SAP 2000. So we can see here it's given assign. So assign joint and restraint. Now, where do you want to assign joint and what type of joint? So we have by default 4 different. One is the fixed support, hinge support, roller support, internal, no restraint. So do you want to assign it here? Yes. What kind? Feet. And apply. Then we have another support here, that is roller support, and then you can click roller and then apply and then OK. That's all. Now we can see at point D we have 40k load downward, so we have to assign that. So to do that, first select the point where you want to assign the load, which is point D in our case, and then we can go to assign. So easy, just go assign joint load forces, and if you remember the force was downward, and do you want to assign that as a dead load? Yes, we want to. Do you want to consider it as a global coordinate system? You want to consider a global coordinate system or local? I'll talk about these two, global and local, in the next lecture, and there we will learn how to assign loads at different angles. So then we will need these global and local, but here the global and local are same, so I won't need to change that. Then do you want to assign load at the force at global X, or the force in global Y, or global Z? This is Z, so I can keep that global Z. And how much was the load? The load was 40k. So it's already there, 40k, but we will have to select minus sign before, because that is what the SAP 2000 automatically select downward. And do you need anything here? We don't need to apply any moment X, moment Y. No, there is no such moment. So you want to apply this in addition to something else, like in addition to any other type of load. So if you want to add that to previous load, you can add. If you want to replace the previous, you can replace it. But in our case, there was no such load, so it doesn't matter for us. Then you just apply, click apply, and you will see you have the 40 kf. Now, if you remember, in trusses, we don't have moments and shear force, therefore we have to go here and select the whole members, and then we have to release partial fixity. So assign frame release partial fixity, and for moment 3, which is the major, and then we will keep that as 0. Apply. So now partially released. Last thing, we need to run the model. So to do that, we do not want a dynamic analysis, we just want to analyze the current structure per dead load, and then therefore we have to make it do not run, and then eventually we need to run now. Click run now. So you have to save it. Let's say I'm saying this is lecture 1, problem 1. So okay, you can see we have already run our model, and now we can see we have some reaction forces at point A and E, which is 20 and 20, and the total force was 40 kF, so therefore it's balanced. Now if you want to see the axial forces, you can just go here to axial force and then apply, and you can see the show values. If you want to see just build diagram, you can apply that too, and then you'll see these colors. And if you want to see values, you can see values. So here is a minus 44.72, and then 40, and then OK. If you want to see further details, select this one, and then right click. You will have another window, and you can see this compression. This number is in compression, and which is 44.72. And the minus sign show compression, and the plus sign show the tension. And if you want to see the deflected shaft, you can see that too. And if you want to go back to see the joints, just click here, and then you'll see the reaction forces. So this is just one of the example of a truss problem, 2D truss problem. And if you have any question, please leave in the comment section. In the next lecture, I'll talk about some other type of truss problems where we will have different loads, and we will also have some supports with different angles. I will show you how to rotate those support and how to apply an inclined load in the truss problem. That will be a big fun for all of us to know how to use SAP 2000 in such situation. Thank you for watching, and see you next time.